Good morning. So we will solve a set of problems on chapter 2. I already solved part of these in the first section, so I will solve other problems so that you can benefit uh, from different problems. You can watch the recordings. For the first problem, you have to determine the number of members, joints, and mobility for each of the planar linkages shown below. Let us do this example here. So we have this example, and we want to determine the number of links and number of joint in this case. So if I start with the figure here, this is a ternary link. So this is link 1. This is another link 2. Another ternary link here. This is 3. This is number 4. This is number 5. This is 6. And this is 7. So in total, in this closed mechanism, I have the number of links is equal to 7. Now, concerning the number of joints, all of these joints are of revolute type. So I can count them. This is 1. Here you have a multiple joint. Sorry, this is not a multiple joint, it just relate 2 links. So this is also 1. So please pay attention. Don't confuse between, if you look here, you have 3 lines. It's true that you have 3 lines here, but this doesn't mean that it's a multiple joint because this is 1 link. Okay, so always identify what is this link is connecting which, this joint is connecting which links. This is 1 link because it's a ternary link, and this is a binary link. So since it's just connecting 2 links, it's counted as 1. So it's a full joint, not a multiple joint. So this is also similar procedures. This is not a multiple joint because these 2 sides are part of 1 link. So this is 1 also. This is 1, 1. So all of your joints here are full revolute joints. You don't have any multiple joint in this figure. Now, if you count the total number of joints, you have 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in total, we said that the number of joint is 9. And for the number of links, so let me check what we obtained before. Yes, so we have 7 links and 9 joints. So if we replace into the equation of degree of freedom, L equal to 7 and J equal to 9, then we obtain that the degree of freedom is 3 times 6. سوري نحن قد طلع لنا joints 8 أو 9. Let me check again. 1 2 كلهم full. 3 4 5 6 7 8. Okay, so it's 3 times 7 minus 1, 3 times 6 minus 2 times 8. So we got 18 minus 16, 2 degrees of freedom. So if we want to control this mechanism, we need to have 2 controllers, 2 actuators. So for example, here we didn't specify where the ground is. Any of your links can constitute the ground. Okay, so for example, you should take a frame. You can fix this frame to any of your links. Let's say, for example, you say this is my ground. Okay, then you can, for example, to control the system, you need 2 actuators. You can put 1 motor at this level to control the rotation of this link, and 1 other motor here to control the rotation of this link. In this way, you will be able to control the position of all of your links. Once you impose these 2 inputs, you can then impose the output you desire. Let me check your charts. مبلا 8 في واحدة عديناها زيادة. Yeah, it's 8. يعني if you count كلهم 1, if you count them it's 8. 1 2 3 4 5 6 7 8. عدينا 1 بالغلط زيادة. Okay. So this is for this problem. Now, another problem. Here you have two planar linkages systems. We studied in the last section this one. So now we'll consider the other part. So they can give you a figure, and you can determine from this figure the number of actuators needed, or the degree of freedom or mobility. So if they ask you what is the actuator's number, or what is the mobility, or what is the degree of freedom, this means the same thing. So the procedure will be to count first the links and then the joints, and then apply Grubler's equation. Okay, let me zoom it a little bit, and let us count together the number of links and number of joints. So this is the figure of part B. I will zoom it. Okay. So here, the idea is that I have like a system with a body, and the body is connected to wheels. So this system can translate, okay? So my reference will be the body of the system. The body for me constitutes the ground, so I can put this symbol. So all motion of my links will be determined relative to this body. And this body can have translation, okay? So now, the first link will constitute the body of this part, and it constitutes number 1. Everything connected to it, then we consider that it's the same ground. Okay, so here, for example, this is the whole part. This whole part constitutes the ground. So here you have several links connected to the ground. So the ground is a very high order link here, because you have how many nodes it has? You have 1, 2, 3, and 4. So this is a quaternary link. The ground constitutes a quaternary link because we have 4 other links connected to it. So it has 4 nodes. Okay. Now, sorry, look, this part, this one, if you want, is not, you don't count this one, because this one is for the wheel. Okay, and the wheel is not a part of the mechanism. And pay attention for this. So just you should look at these are the links of your mechanism. Okay. The wheel will give the translation motion to your reference, but it's not a part of the mechanism. So when you want to determine the order of the ground in this mechanism here, you just count the number of nodes which are related to links of the mechanism. So here it's just 1, 2, and 3. Okay, because the wheel is here to cause translation of your reference. It's doing something else. It's not related to the mechanism we are studying. So in this mechanism we are studying, we are relating 3 links are related to the ground, so it constitutes a ternary. Okay, now we'll start to count the number of links. Let me check your charts. Yeah, the wheel will move the whole body. Okay, the wheel will move the whole body. It is it will cause the translation of your reference, but with respect to the reference, if you want, I just consider the motion of the mechanism with respect to the reference if I'm fixed to it. I don't care for the translation given by the wheel. The wheel has just a purpose to translate the whole system. But when I study the mechanism, I study its relative motion with respect to the body. Okay, so I consider that the body is my reference and it's fixed. It constitutes the ground. Okay. No, wheel is not counted as a link. No, because it's not a part of the mechanism I have here. If you want, what is the idea of this mechanism? هيدي مثل الجرافة, let's say. Okay, أنت the wheels are just present to displace it from one location to displace the whole system from one location to the other. But when I want to operate in general, maybe حطوقة في الcar, and I will operate my, I will control my system to move this part relative to the body. Okay, فالwheel is not counted as a link in my mechanism. No. Okay.
دكتور
نعم.
in such a case بيكون specified بالسؤال انه انت بدك مثلا degree of freedom تبع الميكانيزم هيدا with respect to the body.
لا بس ما هي الفكرة انه هو شو البيربس حسين of the mechanism. يعني
انه
انت
اكيد متحرك الايد.
يعني واحد هو لازم يعرف شو هو الميكانيزم هون وانه الويل is not a part of it. لانه الويل بيأثر على الموشن of the frame. بس انا بس ادرس ميكانيزم بيهمني شيء اذا الريفرنس is moving or fixed.
لا ما بيهمنا.
لا انا بس اخذ ميكانيزم فيني اخذ حيلا one of its links هو الريفرنس واعمل ستادي له. يعني الريفرنس اذا moving or not will not affect the degree of freedom of the mechanism. وبما انه الويل is just affecting the motion of the body relative to the absolute frame, يعني ما حيأثر على degree of freedom of my mechanism. So I will not count the wheel as a link, and I will not count the connection between the wheel and the body as a joint. Okay.
تمام.
So once I say this is my body of interest, I just want to consider it as my ground and I'm fixed with respect to it. ما بيقعد بيهمني if it's translating or not. يعني the wheel will only control the translation of my system, but will not control, if you want, the degree of freedom, will not affect in any way the degree of freedom of my mechanism. So the presence of the wheel will just move my frame or not. Okay. So now let us count together the links. The first link is the body, which constitute for me the reference. This is why I put the symbol of ground on it. Now, the second link is here. This is what? This is a symbol of what?
Hydraulic.
Yes, this is a hydraulic cylinder. Okay, this is a hydraulic cylinder. For the hydraulic cylinder will allow translation, if you want, translation between two links. So we have this part constitute link 2, and this part will constitute link 3. And the joint between them is a full slider joint. So now when we count joints, this is a full joint. It's a slider joint. Now, this hydraulic cylinder is connected to this part. Okay, let me follow this part to know its extremities. So this whole part constitute one link. This is one link, and it's a high order link. It has several connections with other links of the mechanism. Let me erase the remaining part. So this is one link. It's starting from here and it's ending at this level. So if I want to know the order of this link, I can count the number of joints or number of nodes related to other parts. So you have already one node related to the ground. You have another node here related to another link of the mechanism, which is this one. You have also this node connecting to link this link, which is link 7. This node is linking link 4 to the hydraulic cylinder, and you have here another node linking it to this part, to this part, which is a very important part, لأنه هي يعني بالجرافة هي البارت اللي حتكون مثلا in contact with the ground وحتخلينا نحمل قصص. Okay, so how many nodes do we have here? 1, 2, 3, 4, and 5. So this is a pentagonal link. Okay, so we were counting ground as 1, 2, 3. This is link 4. Link 4 is attached to this part, which will be in contact with the ground. This is part 5. If I continue, part 5 is attached to another link here. This is a binary link connecting 5 to another link. So this is 6. This is another binary link in my system. This is number 7. Now I can detect the presence of another hydraulic cylinder here. For a hydraulic cylinder, it always involves 2 links. So this part constitute link 8, and this part constitute link 9. And you have, this is connected to a ternary link number 10. Okay, because you have 3 nodes connected to other links. This one connects 10 to 9. This one connects 10 to 4. And this one connects 10 to another link that we didn't count yet, اللي هو link 11. And in this way, I have counted all links in my figure. So I have in total 11 links in my mechanism. Now, any question on how we counted links before going to joints, moving to joints? Okay. Now, moving to joints, okay, I have first a revolute joint here connecting link 2 to the ground. So this is a full joint. I have here a slider joint because of the presence of the hydraulic cylinder that only allows translation. So this is also one. This is a full joint, one, also full revolute joint, revolute joint. What about this one? How many links it's connecting, this joint?
It's a double joint.
Double
It's
joint,
connecting-
yes, it's multiple joint because you have 1, 2, and 3. Okay, so it's connecting 3 links, so it's a multiple joint. It's
Counted
counted
as
as
2.
2. You have here a slider joint in the hydraulic cylinder. This is a full joint 1, also full joint, also full joint. 1 second, okay. Also, this one is full, full, and full. Anything else missing? So let us count. 1, 2, 3, 4, 5, 6, 7.
في واحدة ما حسبناها بعتقد.
ايه هيدي يلا هلا
صح
بنزيد.
هيدي.
اوكي. فاذا قلنا 1 2 3 4 5 6 7 8 9 10 11. في شي وحدة بعد ما عديتها.
التو.
بس ليكو بس يكونوا كتار انتبهوا، يعني معقول كتير تنسوا شيء، فخليني ادورهم هلا تنعدوا مظبوط. 1
في واحدة كنت حاطة عليها سطر أصلا.
كنت حاطة عليها سطر، انتبهوا لهم هول. اوكي،
في التو ما
1
عديتيها.
2 3 4 5 6 7 8 9 10 11 12 and 14. Okay, so pay attention to not forget anything or count something 2 times. So J is 14 and N is 11. Then can you tell me there is a way to predict the degree of freedom by such bodies? تعرفوا بالجرافة عادة مين بيعمل كنترول للموشن؟
اللي عم بيسوق.
بشاتش ميكانيزم مثل الجرافة مين بيعمل كنترول عادة؟ عندكم شي motors placed هون to control؟ يعني انتوا اذا بتطلعوا على الجرافة عادة بتشوفوا موتور محطوط على الجوينت مثلا to control rotation of a link. If you observe it well, yes, if you observe it well, عادة يستعمل ما بيكون في motors to control the rotation. فبيكون الهيدروليك cylinders هن الاكتويترز. هلا مش يعني مستحيل نحط motor، اكيد we can. You can put a motor here and you say then I can control the rotation of link 11. So it's possible to control with a motor. But in case you don't observe the presence of any motor on your system, مفروض ساعتها انه الكنترول بس يكون through the the hydraulic cylinders. So here we have 2 hydraulic cylinders only. We can expect that the degree of freedom will be 2. Let us verify. The degree of freedom is equal to 3 times L minus 1 يعني 10 minus 2 times 14, which will give you 30 minus 28, so it's 2. Okay, so here the degree of freedom is 2, so we need only 2 controllers. It's easier to control يعني بوجود hydraulic cylinders they will be the controllers. هلا in case مثلا طلع لي هون degree of freedom أكتر, I can add a motor and control, أو I can ساعتها بالميكانيزم I can add another hydraulic cylinder. Okay, so in general, because hydraulic cylinders are easy to control, بsuch system مثل الجرافة, we use them as actuators, and the degree of freedom will be equal to the number of hydraulic cylinders that we have. Okay. هلا منا general rule على طول نستعملها انه number of hydraulic cylinders هو degree of freedom, because as I told you فينا زيد يعني حيلا هون if I have degree of freedom larger I can add a motor. بس عم اقول انا in practical cases بsuch mechanisms مثل الجرافة in general we rely more on hydraulic cylinders to do the control. Okay. Okay. Any other question on this before we move to another problem? Okay, I did this one for the previous section. I will do this one for you. So here in the following figure, you have a sketch of a kitchen appliance carrier used for under-counter storage. It's shown in the figure. Draw a kinematic diagram of the mechanism. When they ask you to draw a kinematic diagram, you should use graphical symbols we learned together to represent this mechanism. Okay, so let us try together to identify what are the different parts and to draw the corresponding diagram. First, I should consider the ground. Okay, the ground for me here, let's say we have like a table here or a counter, okay, to which the mechanism is fixed through this part. So I consider that this is my ground. Okay, this is fixed to the counter, so this is my ground. And now I have first, what is the order of this link?
Third order.
طيب تذكروا منيح بس قول third order يعني it's connected to 3 other links صح؟ طيب أول لينك هو حسين هو الجراوند. شو هو تاني واحد؟ أنت عدت 3.
السبرينج.
السبرينج is the spring a link شيء؟
I don't know.
No. Look, please pay attention. نحن وقت بلشنا نحكي بلينكس شو كانت one of the conditions to consider it a link in a mechanism? It should not be what? It should not be
non-deformable.
Non-deformable. When you count links, you just consider non-deformable rigid bodies. A spring is a deformable body. It will not be counted as a link. هلا شو الهدف تبعه؟ أكيد عنده purpose. هيفوت عنا بالanalysis للkinetics لأنه it will apply a certain force on my link. Okay. But it cannot because it's deformable. It will not, if you want, affect the kinematics of my system. يعني بما انه هو بيقدر ياخد shape اللي بده اياه. اوكي منه rigid يعني ما حيأثر على degree of freedom تبعي. Okay, so when I draw the kinematic diagram, any deformable body in my system is not accounted for. Yani my spring will not be represented in the kinetic diagram. And then I don't consider that this is a node. This is not considered a node because by definition, a node will relate two links, which are rigid. Okay, so this is a normal binary link. I count just this node and this one. Okay, and in this case I will have, if you want, a 4-bar linkage system. هيدا ال simple 4-bar system فهيطلع I can expect إنه degree of freedom will be 1. So this is هيدي البارت كلها سوا constitute هيدي binary link. انتبهوا ما خص الجيومتري بالاوردر، يعني هيدي الجيومتري يمكن قريبة على triangle بس منه third order هيدا third order link لأنه it's only connected to 2 other links of the mechanism يعني it's a binary link. اوكي بس it's of interest يعني ليش عاملين له هالجيومتري because we want to place something on it. okay we want to place something on it and displace it from one location to the other. So this is the purpose of this part. This is why we do this geometry. Okay. So you can yes.
ما بنعتبر الاوفن جزء منه لهيدا الميكانيزم انه نحن هدفنا نحركه للاوفن.
مزبوط بس انت الاوفن عنده motion relative to this link شيء؟
ما هو اذا عمل سلايد حيعمل ترانسليشن ساعات.
اوكي مزبوط. هلا هو اذا عمل سلايد بس هو الفكره انه انت مفروض تحط object and you want to move this object from one location to the other. هو منه related directly to your mechanism منه part of your mechanism. انت بتشيله وبتحطه صح؟
Yes.
Okay. يعني الميكانيزم هدفه بس to through this shelf to displace an object that you put on it. Okay. So this is why you don't consider إنه الميكروويف is a part of your oven. أصلاً تيكون part بده يكون في شي force that will keep contact always. يعني بده يكون مجبور يضل part of mechanism all time. مش إنه فيني شيله وحطه ساعتي اللي بدي. Okay. So spring, yeah, spring is not a link exactly. So now if I want to represent this mechanism, I can just do this. This is my ground. I can represent it by these symbols. So I have here the first link connected to the ground. This is a second link connected to the ground. I disregard the spring. So I just consider, so link 1 is the ground. This is my second link. This is my third link. And I have like, this is link 4. This link, how can I present it? Because of this geometry,